So we're going to be talking about the Eclipse IDE in this session, specifically the Java developer tools, and our experience integrating that with a technology called Bazel, which is a build technology. So my name is Peter Laird, and I work for Salesforce, so big multinational company. And I work on a microservice infrastructure team at Salesforce, so it's a small team. And what we focus on first is providing runtime libraries for a bunch of, so hundreds of microservices that run within Salesforce. So those runtime libraries provide like metrics, support, logging, RPC technologies, et cetera. That's what we started with, but we realized all these microservices teams needed also help with their build system and deployment. And so we built what's called a monorepo, and that I'll explain a little bit more what a monorepo is, but we also assist all of these microservice teams building and deploying their applications as well on top of our libraries. And there we go. So just at a high level, what we're going to cover, I'm going to talk about Bazel, what it is. I'll talk about the Bazel IDE landscape as it exists today. But obviously, I'm here at EclipseCon to talk about what we've done, which is integrate Bazel with Eclipse. So I'm going to give you a quick tour of that. And then I'll explain how we accomplish that integration. And then finally, I'm going to talk about some of the interesting problems we hit when we were doing that integration. Before we talk about Bazel, I'm going to quickly explain what a monorepo is, because Bazel is normally seen in the context of monorepos. So a monorepo is just a large source repository with, hundreds of projects in there from many different teams. Usually there's dependency relationships between all those different modules. And so one of the big benefits of a monorepo is if you make an upstream change in a library, all the downstream microservices, in our case, immediately get that change, and we see if we break any tests. So it's a great way for the entire ecosystem of microservices, in our case, to all stay up to date on the latest code, and we make sure we don't break anybody, so everybody's happy. It's also, supply chain attacks are a big topic these days, so it's also a very convenient place to manage all your open source dependencies. So if there's a vulnerability in Log4j, for example, you just have to fix it in one place, and hundreds of microservices are automatically updated. So that's what a monorepo is. There's different factors that would encourage you to go with a monorepo approach. Since this isn't really a monorepo talk, I'm not going to go through those, but come talk to me afterwards if you're thinking it might be a good architecture for you. And the reason I bring that up is because Bazel mostly is seen in the context of monorepos, not always, but that's typically where you see it. And so Bazel is a build system. It was open sourced by Google. So this is the build system they use internally to build all of the Google products in their enormous monorepo. You can kind of compare it to maybe Gradle or Pants, if anyone uses those build technologies. So it's essentially a homogeneous layer of build technology with lots of different plugins for all the different compiler stacks and technology stacks like gRPC, Lombok, those kinds of things. And so what's nice about it is it's a single technology. Your build team doesn't need to know all the different build tools that your stacks are using, because it's just Bazel, and they just invoke Bazel commands for you. It has a really high focus on reproducibility, and so they go really far out of the way to make sure that a build that works on that machine will also work on this machine, and the artifacts that come out of it are exactly the same, regardless of whether you run it on that Mac over there or that Linux box over there, down to the byte level. Like they do a really good job making sure that those artifacts are the same. Also has a lot of built-in scalability features. This is what attracted us to it. You do these big builds, and a lot of those intermediate steps have been done before by another machine. And so they support what's called remote cache. And so you can just cache those artifacts. And so the next build that comes through to build those exact same source files at the exact same version they don't have to build it. It just pulls it from the remote cache. And then also, there's a feature called remote execution that's built in, which allows you to farm out a single build across many different machines. Because they have a very good idea of the dependency graph, they're able to figure out which steps need to be done first, and then what steps thereafter can be done in parallel because there's no shared dependencies. And so we use it within Salesforce in multiple monorepos that we have. But I'm going to be just really mostly focused on the one my team uses, our builds. And once again, Bazel is best suited, although you can use it for very small projects. There's nothing stopping you, but usually you see it. So BazelCon is in the next couple of weeks. It's mostly big companies, frankly, but smaller companies can use it too. And this is what Bazel looks like. Once again, this is, it's not really a Bazel talk, but just to give you an idea, in the Java world, we have three main primitives. The Java library, which produces a jar file. We have a Java binary, which is a runtime application, and a Java test. And so in this is what's called a package. In a directory, you put a build file. And in that build file, you can have many different targets. And so, and that's what those targets look like. And so it's a pretty easy to understand build language. What's interesting about it is you can have many different Java libraries in the same package, and that's going to cause some problems, as I'll talk about later when I integrate it with JDT. All right, so let's talk about the IDEs. So Bazel, once again, is a build system. It's not a language. So when you talk about IDEs, you're really relying on the existing Java plugins for whatever your IDE is. But the IDE does need to comprehend your build system because that's what produces the class path. And that also affects how you're launching the application or launching your tests. And so that's what we mean by IDE support for Bazel, is really those two major line items, the class path and launching. Okay, so and today the landscape looks like this. IntelliJ is the officially supported IDE for Bazel. So this is what the Bazel community uses. And the reason is because Google, as they were building Bazel internally for 10 years, they were also working on their IntelliJ plugin. And so when they open sourced Bazel about 5 years ago, they also open sourced their plugin. And it's robust. It works great. It supports a lot of different languages. And JetBrains has actually taken it on as, they're helping to run the community now. So that is that's the way to go for the most part. So that's the default solution. But there's also two more options. One is Eclipse, I'll be talking about in the next few slides. But also Salesforce is also supporting, we're also implementing a Java language server that's Bazel aware, so that we can support VS Code and maybe Thea. And what's cool about that is those two projects, the Eclipse project and the VS Code, or the language server projects, share a lot of code. Okay, so Bazel Eclipse Feature, the reason it exists is in 2018, we were going around Salesforce trying to get all of these microservice owners to move into our new monorepo with this new build system called Bazel, which no one had heard of back then. And so we were talking mostly to managers saying, hey, why don't you move in, and then we'll take care of all your source code maintenance for you. And those conversations would go great, except these managers kept saying, well, what about my Eclipse users? There's IntelliJ support, but there's no Eclipse support. I don't think we can move in because Bazel doesn't have Eclipse. And so as a hackathon project in 2018, I took this on. There was a very early prototype of Eclipse support released by Google. They had done it in 2016. I took that and then added a bunch of stuff to it and got it working. And then through 2018 and 2019, my team would try and work on it. We have a lot of priorities, but we would actually spend some times in our sprints working on it. But by 2020, it was very workable. It supported our monorepo perfectly. And it does, all the things you would expect. It's Java only. That's the big limitation. So we're only supporting Java. If you have Kotlin, if you have Scala, no, no, no. Go, we don't do, but we do Java. It's open source. It's available out there today. But at that time, in 2020, we had a big reality check. All those managers had said Eclipse support was really important to them, but their developers disagreed. As we brought in more and more teams into our monorepo, we found that devs weren't asking for Eclipse support. They were just rolling with IntelliJ. And we knew we had some issues, and so that was why we knew we would get questions if people were using Eclipse a lot, but we didn't get those questions, so we realized that, hey, you know, all these developers are just switching to IntelliJ and they're not complaining. So that could have been the end of it, frankly, you know, because there's no funding within Salesforce to just do Eclipse for the fun of it. So, but I'm here today because that was not the end of it. And the reason is because what we're doing in Eclipse is differentiated from IntelliJ for several reasons. First, we don't have to support the entire Google code base. Apparently, the Google code base has all sorts of, you know, edge cases in Bazel, all sorts of, you know, really interesting dependency hierarchies. We don't have to support all that, so we can be a little more opinionated about what Bazel configurations we actually support. And in doing so, we can actually be a little more accurate in some of our computations for classpath, as one example. Also, by supporting only Java, we have a very small footprint in terms of testing, and so we have Windows support, whereas the IntelliJ plugin does not have official Windows support. And also, we are doing the language server as well for Bazel Java. And 90% of the code that we have written for the Eclipse plugin or the Eclipse feature is shared with our VS Code or the language server project. Only 10% of the code is Eclipse specific. So it's the investment we make ongoing in Eclipse is shared across the two projects. So it does make sense for us. But I would say, you know, our investment right now for Eclipse is, in American business language, there's a word called aspirational, which means it's not in your top, you know, handful of priorities. So we're still trying to work on it, but it's not getting heavy investment, whereas we do have real investment in our language server, and so all the features done for the language server will be coming over to Eclipse. Okay, we're going to do a quick walkthrough. We're not doing a live demo. So it installs off the marketplace like you know, any feature you would expect, and it integrates with the import wizard capability of Eclipse IDE. Probably like you would expect, you'll have a new option once you install the Bazel Eclipse feature to import a Bazel workspace. And so when you do that, what we do is we ask you to identify your workspace location on disk. And so we go in there and we scan your Bazel workspace. And what we're looking for are packages. So Bazel, every essentially module in Bazel is called a package. And what we're looking for are packages in your workspace that have Java targets in them. So Java libraries, Java tests, et cetera, Spring Boot as well. And then we let the user select just a subset of them, so they don't have to import their entire workspace, because in our case, there's over 400 packages that you could import, and that no one wants 400 Eclipse projects in their IDE, so you're allowed to then select which packages you want to import. And then we do the heavy work, and that is computing the class path for each of these projects that have been imported. And so we use Bazel for that. Bazel has very sophisticated ways to obtain the dependency graph of a project, and there's several different ways to do it. And we use multiple different ways depending on the situation. And then we also identify all the source folders in each package that you have, and let JDT, so we have to provide this information to JDT and say, okay, here's the class path and here's the list of source folders. Once we do that, JDT just takes over, and the editors open up as you expect. You get error highlighting, and you can do code completion, you can do refactorings across projects even. One thing that we really speak highly of JDT for is, yeah, once we do those two basic things, source folders and class path, JDT just really takes it from there, at least from the editing point of view. And the way we implement that is, you can see over on the left, there's a Bazel Class Paths container, and that's where we've computed the class path for that particular project and given that to JDT. There's a main class path, those are the jars in white, and the test class path, those are the jars in gray. And we just annotate the class path with that information, and we're off and running. Underneath the hood, we're actually executing Bazel builds. And so to ensure we have complete, one of the big goals for this project is to have fidelity with your command line builds. So let's say you build on the command line, you run all your tests, and then you come to your IDE, and then you get a different result for some of those things. That's a very disappointing experience. And so what we do is we delegate all builds down into Bazel. So if you choose to build, we send that to Bazel. Bazel builds whatever packages were in scope, and then we parse the results and then populate the problems view with whatever Bazel found. So, and that's the way we're ensuring that both command line and IDE are in agreement. Also, we support global type search. So, like I said, in our monorepo, there's over 400 packages. You tend to only import maybe 5 or 10 at a time. But there's jar files in the workspace that won't be used by any of those 5 or 10 different projects that you've imported. And so what we do is we create a synthetic Eclipse project called the Bazel workspace, and we put all the jars that are available in the entire workspace into that class path. It's not used ever to build, but it's used by the type search. So, if you, for example, don't have Guava loaded by any of the projects you imported, you can still find Guava classes if it's in your workspace, and then you can add it to your project. Application launcher, we did create a custom launcher. So once you select the project, fruit salad in this case, we'll go and interrogate that package and find out which targets are available. So these are Java applications or Spring Boot applications, and then we'll populate that, and then you can launch it. Testing is a little more interesting in that we do intercept the JUnit launcher. We use the Eclipse standard JUnit launcher, but we actually inject the best class path that we can compute. And I'll explain why in a little bit, but that's why we have a custom Bazel JUnit launcher, just so we can intercept the class path that's going to be sent to that launcher. And we have preferences. Okay, so now I'm going to talk just briefly about the extension points, but really the key statement here is, Bazel is following it on Gradle and Maven. Other build systems have already integrated with Eclipse, and so we didn't have to ask for any features from the JDT team. We didn't have to ask for any features from the Eclipse teams. So everything was just already in the box, and we were super happy about that. So I just wanted to give that good feedback to the Eclipse team. It was great. I'm not going to talk through each of the extension points, if I can get there. We used a bunch of extension points, and we also implemented a number of interfaces. The most important interface, iClassPath container, is the main integration. And once again, we're implementing that because we interrogate Bazel to find out what the class path should be for each given project. Okay, the interesting stuff. So everything went well, except there were some impedance mismatches between Bazel and JDT, and we had to do some workarounds and some changes of plans. But Bazel is more flexible than what JDT really contemplated on the outset, and I'll give some specific examples of it. And so when we first were implementing it, we're struggling a little bit to figure out how to map Bazel into Eclipse because of some of these flexibilities. And so that was kind of the first thing that we understood. All right. But we also, as time went on, we came to understand that some of those flexibilities that Bazel offered could be used in anger, frankly. Like, you could really make a mess of your build. And so we started to question some of those flexibilities, and so that's, in 2018, 2019, that's really what we were starting to struggle with, is how to deal with that. And to be honest, when we started this project, especially for me, I thought my job as an IDE maker was to provide 100% fidelity to my underlying build system in the IDE. So make the IDE really show really everything as accurate as possible. But I came to realize that actually wasn't the best thing in all cases. Really what an IDE should do is give the developer a nice, clear, conceptual view of what's going on in their build. And maybe there's some edge cases that we just don't support. And that was very liberating to kind of come to that decision, because that really allowed us to just disregard some issues that we were trying to figure out the solution for. And so, and also we decided that JDT has been around for 15, 20 years. And so if JDT is not supporting something, that's probably a good sign that it's something we can do without. And so the first thing we decided, this isn't a problem, but it led to some problems, is that in Bazel, once again, you have these modules, that they call them packages. And we decided to map a package to an Eclipse project. And so, and this works, this is the right conceptual model, because a package is a unit of functionality, it's a unit of code ownership in Bazel. And so we did feel that the best map to an Eclipse project. But as I said before, you can have multiple Java libraries coming out of a single Bazel package. You could have 100 different Java libraries coming out of a single Bazel package. Also, every single test within your package is a different unit. But we decided to go forward with this solution. But that led to an issue in that JDT really has, for every project, has two class paths. It has your main class path, and it has your test class path. Excuse me. And so, great. And so give me a minute. So the problem was, in a Bazel package, you could have lots of Java libraries. Sorry, I'm a mess. And what we have to do is create a union class path, which is taking all the Java libraries together and assembling it as a single main class path. And then we have to do the same with the test class path. And so we go through all the tests and find out all their class paths and load that as a single test class path. And so the unfortunate problem with that, though, is in the Java editor, if you open up a Java file, it may give you the wrong suggestion for code completion. For example, if one of your Java libraries has access to Guava, but another Java library doesn't, and you open up that a Java file from that second library, it may suggest that you can use Guava when you actually can't. And so, but the good thing is, and that's just a problem that we have, but the good thing is that problem is quickly identified. So since we're invoking Bazel underneath the covers to do the build, pretty quickly that problem will show up in your problems view, and you'll see that, hey, you actually don't have Guava for that library. And then also, a very similar thing happens with test launching. So that's why, again, we have a Bazel JUnit test launcher, is because that test class path has a lot of different things on there. We want to be very precise when launching your test to only use the things that actually are available to that test. And so we inject our logic there. And then we started rejecting some things. Like one of the things that Bazel enforces is there's no cyclical dependencies between targets. And so if you have a target here that depends on a target over here, this target can't depend back on that target, which makes sense. So two Java libraries can't depend on each other. And that works with Eclipse. But that rule in Bazel does not apply to packages. So it's not totally uncommon to have a Java library in one package depend on a Java library in another package, which depends back on a different Java library in that first package. And so in that case, we can't import that. We can't import both of those packages because Eclipse does not allow that. And so for a while, we tried to come up with different solutions for this, but in the end, we just said, you know what, we can only go so far with this. So, the workaround here is that you can only import one of those two packages. And Bazel, now we're starting to get into weird stuff that we don't really agree with. Like, I don't know why you would do this in Bazel, but Bazel doesn't really have the notion of source folders. It's just really file-based. And so you can put your source code in all sorts of crazy locations, like nested source folders like this. And that's completely legal, Bazel. But once again, I don't know why you'd do that. And so in this case, we just say, sorry, can't do it. Another weird one is Bazel does not really care about your directory structure when it comes to your Java files. So you could have a package declaration of com.acme in your Java file, but it's located in com.demo. I don't know why you would do that as a developer, but that's legal in Bazel. And JDT says no. I don't know why you'd want to do that. So we just said, okay, that's fine. That's just a limitation. There's like 5 more things like this. We're going to end here, but so the journey with Bazel was really about kind of figuring out, okay, these are a bunch of edge cases with Bazel, and we had to decide, can we support it in JDT? And if JDT wouldn't allow, we just said, you know what, that's probably reasonable, and so we just cut it off. I'm not going to provide any more examples, but that was like the exercise that we had over the last couple of years. So as a wrap-up, Bazel Eclipse Feature is out there. It's in the marketplace. I don't know. I did a poll before we started. It didn't sound like anyone was using Bazel. But if you do decide to pick up Bazel and you have Java developers, we're definitely an option. It supports, I think, most common usages of Bazel, most reasonable usages of Bazel, I should say. And then we're going to continue to evolve it alongside the language server product that we're building. So if you have feedback, let us know. If you loaded a Bazel workspace into it and it doesn't work, let us know, because then we can go in and see what's going on and maybe add some code. All right, thank you. Thanks for sticking with me while I was coughing. That was awful. Yes, go ahead.
When you say you launch a Bazel build in the background, does that include compiling? When you launch a Bazel build, does it include compiling Java files? And if so, which compiler is used during that compilation?
Good question. So yes, it does involve compiling Java files if they've been invalidated by some upstream change. And Bazel's pluggable. Java C is the default compiler, but my colleague, I don't know if you know Gunnar, he's worked on plugging in the Eclipse compiler as a replacement, because a different product within Salesforce uses the Eclipse compiler, and so they've done that work to swap out Java C for the Eclipse Java compiler.
Because otherwise you would see all the differences between the compilers.
Yes. Yeah. So in our repo, we don't really have those kind of edge cases, I would think, but that other product that we have hits all those edge cases. And so, yeah, that was why it was important for that team to use the Eclipse compiler. Yeah. Good question.
Do you support incremental builds?
Yes, so Bazel by itself is highly tuned for incremental builds. And so they have a very clear understanding of the dependency graph. So if you have, let's say, 10 projects inside of your IDE, and you make a change to an upstream one, it will only rebuild the downstreams. And then within a package, it's kind of up to you to control that. Bazel allows you to create multiple targets. For example, if you have like a large source tree within a single package, you can create multiple targets. And that's the reason why you would create multiple targets, to say, okay, these directories over here are one package, and then this down here is another package. Also, it has local caching, and so between all these different layers of caching and dependency analysis, it does a really good job of incremental builds. Maybe not as perfect as other build systems, but it does a pretty good job.
Okay, if you import only a part of the workspace into, or part of the project into your workspace, how are the other dependent projects are resolved?
So that in our import logic, in our class path logic, we have to be aware of a dependency. If it's already been imported, then we switch it to in Eclipse, there's project references. So on the fly, we have to make a decision, okay, project B here that I'm importing depends on project A. If I've already imported project A into Eclipse, it becomes a project reference. But if I haven't imported project B, it's there's a way in Bazel to refer to the product of that project, so the jar file. But yeah, we have to do that switching on the fly, being aware of whether your dependencies are also loaded.
You have mentioned about code completion, but you are not changing any code, right? So how does that come into picture?
I guess I don't understand the question.
In one of the slides,
Yeah.
you had mentioned about there is a problem with code completion because,
Okay.
but you're not changing any code, right? So how does the code completion part come into picture here?
Well, you are. So it's an IDE solution. So you can do development in the IDE, but then let's say there's a Spring class or a Java class or a Guava class that you want to use, and you put that in your and the project does not currently depend on Guava. What you can do is, as you type it, code completion can. So what you're, I guess the right answer is if actually the use case is if there's multiple libraries within the same package and one uses Guava and the other doesn't, it's actually not legal to use Guava in the second library. Right. But because of this class path issue that we have with JDT, you're going to have access to Guava even for classes in that second library. And so it might offer, that Guava class, and then if you try and use it, you'll get then a build problem to say, hey, you're not actually allowed to use that.
Okay. Yeah, so that's a fundamental.
But then we have a quick fix. So we implemented an extension to JDT for a quick fix to then offer up, hey, you need to add this particular jar to this particular target.
Yeah, that's true.
So we implemented a custom Bazel quick fix for that. Yeah.
Okay.
One more question. Every time I hear talk about the class path, I wonder if any projects are migrating towards the module path, JPMS, Java 9 modules.
We aren't.
Good answer.
On one of the screenshots, there was a open type dialog.
Yes.
With all the classes tripled. Is that a follow-up problem of the class path unification, or is that something else? Yeah, but if it's probably my best guess it would be that the jars are the same in the workspace project and the individual project, so every jar should only be represented once, but I see all those 3 times, so I'm confused.
Good eye. When I was making this, I'm like, we have a bug. So one of the reasons is Bazel creates header jars, so essentially like interface jars. And so what we're showing here is we've actually scanned multiple copies. And the third one, so that's why we have 2. I forget why we have the third, but yeah, I was hoping no one would see it. But yeah, we have a bug. We need to, as we're building this global class path, we need to make sure not to scan in the header jars. And so Bazel uses header jars to be able to quickly determine if interfaces have changed on a Java library, because then if interfaces haven't changed during a build, you don't have to rebuild anything downstream. You have to retest, but you don't have to rebuild because the API hasn't changed. So it's an optimization of Bazel.
And a somewhat unrelated question, would you choose Bazel again as a build technology?
Yes, that's a good question. And you could also ask, like, how does Bazel compare with Gradle? And there are, a number of blog posts out there that talk about that. One of the things that is really appealing for a big company like Salesforce is having freely open source solutions for the remote build cache, the remote execution. That being said, we got into Bazel maybe a little early, so we had some more pain than maybe if you were to start today. So, and also, for example, we're a Spring Boot shop. We use Spring Boot a lot. So I'm the rules maintainer for Spring Boot in Bazel because that didn't exist. And so I think starting today, it's a much easier ride than what we had to go through. So, but yeah, we're happy with it, and it's. We have a handful of instances now within Salesforce across the world of people using it, and it's holding up. Everything that it's promised, it's doing. And so it's really whether switching out a build system for you is cost effective. Like it's a big project. It's going to be a lot of work. There's tons of converters out there going from POM XMLs to Bazel build files. Everybody writes one. It's one of those kind of projects. And so there's plenty of migration support for, especially Maven to Bazel. So yeah, it's good. All right, thank you.